In this video, we show how we designed and built a self-decorating cake module that transforms an ordinary birthday cake into an electronically controlled spectacle.
Happy birthday.
We used our custom-built circuit board to orchestrate the performance and designed the 3D printed parts using CAD software. We disassembled a common barbecue lighter and repurposed its components to build a pyrotechnic device for lighting the candles on our self-decorating cake. Pulling the trigger depresses the black igniter shaft, generating a spark while simultaneously opening the fuel valve by moving the white tab. We removed all the extra parts and shortened the lighter neck, leaving only the tip. We temporarily secured the lighter nozzle with zip ties and tested the flame to ensure it still worked. We were able to manually operate the lighter by pressing down on the igniter shaft with one finger and activating the fuel valve with another. Then the ground wire was secured to the tip. The end of the ground wire was positioned at the perfect distance from the fuel exit. Too close or too far away would prevent the fuel from igniting. The fuel valve was adjusted to the maximum setting, and the igniter was tested once more. Next, we used a digital gauge to measure the amount of force required to activate the spring-loaded igniter mechanism. This helped us select a linear actuator with sufficient capacity to get the job done. We changed the units from newtons to pounds and set the meter to capture the peak measurement. The force gauge registered 5.3 pounds. We purchased an actuator rated at 42 pounds of force. This was overkill, but it was sure to get the job done. We 3D printed a mounting bracket for the fuel reservoir and actuator. Next, we 3D printed a crossmember and attached it to the actuator. When pulled down, it simultaneously engages the fuel valve and igniter. Here you can see our custom circuit board, motor driver, and remote control receiver. We programmed the electronics to move the actuator up and down in response to a signal from the wireless key fob. We connected the actuator to the motor driver output. The motor driver circuit converts the low current, low voltage command signal from the microcontroller to a 12-volt output capable of driving the actuator. Next, we powered the electronics and tested the mechanism using the wireless remote. When the microcontroller receives a signal from the remote control circuit, it sends a command to the motor driver, activating the actuator. We assembled the candle mechanism and programmed the microcontroller to send a pulse width modulated signal to the servo, rotating the candles to an upright position. This action occurs after the candles are lit during the finale. We uploaded custom audio files to the sound module and connected it to our circuit board. After analyzing its operation, we found that pressing the button pulls a 5-volt signal to ground, triggering the next audio file to play. To automate this, we programmed our microcontroller to ground the input, simulating a button press. This is what the playback sounds like when activated.
Happy birthday from Smart Circuit Engineering. Go ahead, blow out the candles.
We 3D printed 2 cannons designed to blast sprinkles and edible glitter into the air. To operate the cannons, we built an air reservoir using PVC pipe and brass fittings and purchased 2 12-volt electric solenoid air valves. For the first test, we manually triggered the cannons by connecting a battery directly to each valve. Then we designed and built a reservoir specifically to fit within the tight space of the self-decorating cake module. We filled the reservoir with air and ran another test, this time using our circuit board to automatically trigger each valve. Next, we attached the cannons, filling one with sprinkles and the other with glitter. This time we used a 3D printed funnel. We bought a small cake to test our method for inserting the mechanism into the center of a birthday cake. We 3D printed a custom cookie cutter style tool to press into the middle. This made it easy to remove the cake's core, creating a space for embedding the self-decorating module. This test gave us confidence that the technique will work on a larger cake. Don't worry, this plate didn't go to waste. We designed and 3D printed a larger version of the cookie cutter tool to be used later on a larger cake. A total of 34 3D printed parts come together to form the self-decorating cake module. To test the doors, we connected the servos to our circuit board and programmed it to send a pulse signal to each servo. We selected this 3 amp-hour, 12-volt battery with a built-in on-off switch to power all the electronics. Next, we installed the individual components into the tight confines of the self-decorating cake module and wired everything together. Packing so much into such a small area required extensive design work and careful thought. Here's the completed module, wired and ready for its debut. We attached an aluminum plate to this servo to protect it from the heat of the flame, and we installed a nylon bracket to hold the igniter tip. We ordered a large cake for the main event. This is when the big cookie cutter tool came into play. We prepared the self-decorating module for the final scene and installed it in the center of the cake. It turned out that the cake wasn't tall enough, so we cut a hole in the cardboard bottom and raised it 1.5 inches using pieces of wood, making the top flush with the icing. The first attempt did not go according to plan. The door closed as the sound module was being turned on and the igniter flamed out. Additionally, the cannons triggered prematurely. After a couple more failed attempts, we finally achieved success in our final run.
Happy birthday from Smart Circuit Engineering. Go ahead. Blow out the candles.
Here's a closer look at the action in slow motion, featuring a reverse shot of the cannons, as well as footage from other camera angles. If you enjoyed this video, please hit the thumbs up button. Also, be sure to subscribe and hit the notification bell so you don't miss future content from Smart Circuit Engineering. Let us know what you think in the comments below. Here's the setup we used to shoot the final scene. By the way, if you're wondering how we access the inside of the module after the show is over, we simply press the remote button again.